So now that you've learned how to write reactions, you're actually going to learn how to distinguish between different types of reactions. And so the two that we're going to look at in this lesson are synthesis reactions and decomposition reactions. So a synthesis reaction is exactly how it sounds. You are synthesizing something, you are making it. So you're going to have two different reactants combining together to form one product. Okay, so we've got three different types of synthesis reactions you can have. You've got a 1A, and what's happening there is you have two different elements, element A and element B, and they combine together to form a compound, AB. Okay, for 1B, you have a metal oxide, so that's a metal with oxygen. So for example, you could have sodium oxide, you could have magnesium oxide, calcium oxide, aluminum oxide. It reacts with water and it forms a base. And so we'll look at what makes a base in just 1 second. And then for 1C, what you have is you have a non-metal oxide. So for example, sulfur trioxide, SO3, that is a non-metal, sulfur, and oxygen, O, and it's going to react with water to form an acid. So those are your three different types of synthesis reactions. So let's actually see what all of this means. All right, so remember, M stands for your metal, for a metal oxide, and NM stands for your non-metal. Now, for synthesis reactions, you're always going to produce one product. Now, if you're going to be forming a base, what makes a base is it is a metal and hydroxide. And so in order to write the formula for this, because this is going to be an ionic compound, you need to cross your charges. So for example, if I give you sodium hydroxide as your base, the formula would be NaOH, because sodium has a +1 charge, hydroxide has a -1 charge. If I gave you magnesium hydroxide, since magnesium has a 2+ charge and hydroxide has a 1- charge, then the formula, once you cross your charges, would be MgOH2. Okay? And then for calcium, again, because calcium is a metal with a 2+ charge, hydroxide is -1, it would be CaOH2. So those are bases. For an acid, the formula is hydrogen followed by a nonmetal, and then often followed by oxygen, not always. So for example, H2SO4, that is an acid. You've got hydrogen followed by a nonmetal followed by oxygen. For carbonic acid, you've got hydrogen followed by your nonmetal, carbon, followed by oxygen. Now the important thing for you to know, for 1A and 1B synthesis reactions, to create your product, you're just going to cross your charges. For 1C, you're going to balance as you go. So let me show you that in some practice. All right, so the first reaction I have is aluminum plus oxygen. Okay, and so I look at this, aluminum is an element, oxygen is an element, so this is going to be a 1A reaction. And so what I have to do for this is I've got to combine them together by crossing charges. So aluminum has a +3 charge, oxygen has a -2 charge, and so the formula would be Al2O3. Now the only other thing I have to do here is I have to balance. So since I've got 2 oxygens on my reactant side and 3 oxygens on my product side, I'm going to put a 2 in front of aluminum oxide to make 6 oxygens, and I'm going to put a 4 in front of aluminum, since I have 4 aluminums, and a 3 in front of oxygen. And now I'm balanced. So that's a 1A. Let's look at the next type. I've got a metal, sodium oxide, reacting with water. And so this is going to be a 1B. Now, I'm going to be making a base here. Remember, your base is your metal and hydroxide forming a compound. So my metal is sodium, Na. It's going to form a compound with hydroxide. Na has a +1 charge, hydroxide has a -1 charge, so the formula is NaOH. Now the last thing I need to do is balance. I've got 2 sodiums on my reactant side, so I'm going to put a 2 in front of my products, and I'm now balanced. Okay? The last example, notice here, SO3, S is a nonmetal followed by oxygen, so this is going to be a 1C. Here's where you balance as you go. Remember, an acid has hydrogen followed by a nonmetal followed by oxygen. So I've got 2 hydrogens here, so it's going to be H2 followed by my nonmetal, which is S, followed by my oxygen, which is O. Now, I have 2 hydrogens, so it's going to be H2, S, and then I've got 4 oxygens, so so it's going to be H2SO4, and that's it. Now let's look at decomposition reactions. Decomposition reactions are exactly how they sound. You have one compound, which is going to be breaking apart into other compounds. And there's a nice long list of decomposition reactions, so let's look at them. For 2A, you've got a compound breaking apart into its elements. So that's identical to what we looked at for synthesis, except it's the exact opposite. So you've got a compound breaking apart into its elements. For B, you've got a metal with carbonate, so that could be Na2CO3, MgCO3, and it's going to break apart into a metal oxide and carbon dioxide. For 2C, you've got a metal with HCO3 with bicarbonate, and it's going to break apart into a metal oxide with water and carbon dioxide. For D, you've got a metal and hydroxide, which is a base, and it's going to break apart into a metal oxide and water. That reaction we've already looked at. That is the opposite of your synthesis reaction of a metal oxide and water. For E, you've got a metal with chlorate, MClO3, and it's going to break apart into MCl and O2. And finally, if you have an acid, it's going to break apart into a nonmetal oxide and water. That's identical to your synthesis reaction, again, just reverse. So 2A, 2D, and 2F you've already looked at. And so what I want you to do right now is I want you to highlight the compounds for which you're going to need to cross your charges. So MCO3 for 2B you should highlight, because if you're going to create that compound, you need to cross your charges. MO, highlight. MHCO3 in 2C, highlight. MO, highlight. MOH in 2D, highlight. MO, highlight. MClO3, highlight. MCl, highlight. So those are the ones that when you're trying to create the compounds, you need to cross your charges. Okay? Now there are a lot of different reactions. I'm not going to do each of them, but I'm going to show you 3 examples. Okay? So if you look for the first example, I've got Na2CO3. That is a metal with carbonate, so that is a 2B. So I know that it's going to form a metal oxide and carbon dioxide. Now, my metal oxide, I've got to figure out the formula. So I've got Na is my metal, so Na plus, and oxygen with a 2- charge. So when I cross my charges, because I need to, it's going to be Na2O. And I'm just going to write carbon dioxide. Okay? If you look at this, this is already balanced, so I'm done, and that's all there is to it. Okay? For lithium chlorate, that's going to be, since it's a chlorate, it's going to be a 2E, and I'm going to form lithium chloride, so my metal with chlorine, so it's Li has a +1 charge, chlorine has a -1 charge, so it's going to be LiCl plus oxygen. Okay? And now I've got a balance. I've got 3 oxygens on my reactant side, 2 on my products. I'm going to put a 3 in front of O2, a 2 in front of lithium chlorate, and a 2 in front of lithium chloride. Okay? For the next one, I've got just 2 elements, and so that's going to be just a 2A. So it's going to break apart into its elements, so it's going to be Na, and I'm tempted just to write Cl, but remember Cl is diatomic, so I've got to write Cl2. Okay? Now to balance, I'm going to put a 2 in front of Na, because I got to put a 2 in front of NaCl to make it 2 chlorines. And that's all it is. Those are synthesis and decomposition reactions, and now you get to practice with them.